Hi, I'm Dave here. Today I have a repair. This is a 7000 series plugin. I bought like 4 of those, and I'm going through them, just checking if they work. But this one is a little bit broken. Has the the mechanical part inside that is not working properly. This one is completely disconnected, so it needs some loving care. So this is a 7A13 differential comparator plugin, and I don't know really what's wrong with the designation here, the model number. There's written here, it says 7A16A, which is not. I mean, 7A16A would actually be a single channel amplifier, just a very basic one actually. So I really don't know what's going on here, but probably it actually broke and someone replaced it with another one. But this one is a 7A13 differential comparator. This is the earlier version because it has the mechanical readout here. The later version has a little LED display. But anyways, this doesn't really work as it should. This knob is not original, obviously, and there are a few parts that are not really working properly. So a differential comparator like this is a very useful instrument for a wide variety of applications when you need to, measure, compare the voltage, compare two signals, compare the voltage between two sources, and a number of other things, seeing superimposed signals when you have a very high DC offset, whatever. This one can actually do it, and having a dedicated plugin for it is very cool. It can also be used, obviously, as a normal, amplifier. This is obviously it's going to be a single channel amplifier. It has the voltage, volts per division, everything here, AC, DC couple, whatever. Just you don't use the voltage comparator mode of this instrument, but can be also used as a another channel on your 7000 series oscilloscope. So as I said before, this is the earlier version of the 7A13, so it has the little mechanical readout here for the comparison voltage instead of the LED display. But anyways, this has the little mechanical readout where you can vary the comparison voltage by those little wheels, those knobs that spin some wheels inside, some gear reduction and whatever. But this thing actually needs some love and care. This thing is really hard to turn, and this one doesn't even work correctly. So yeah. Also, this front knob here is spinning. Just it actually came loose inside, and the polarity also doesn't work. And obviously inside is all gold-plated goodness. So yeah, that is really, really cool. And I see those infamous Tektronix relays there. Hopefully those contacts are still good. They usually go bad, and it's very hard to replace those relays. They are not there are custom relays. Those are very hard, if not impossible, to find new old stock. So yeah, you have either to open them up and clean the thing, clean the contacts, or budge in an off-the-shelf relay to replace those. And what do you know? More relays on the other side. All right. And I see even more infamous Tektronix relays under that shield. Oh, jeez. And here in the front, you can actually see some mechanical goodness, and my god, those switches are really good. And look at the shafts, they go all the way from the front panel to the bottom here. That's really cool on those those joints here. Oh, man, that's really cool. And this is the mechanical part we have to check. And I see a 10-turn part here, which is actually turning when I turn the this knob here in the front, but this one on the back should turn this other switch here, but it just doesn't. So yeah, I have to figure out a way to fix it. And I just noticed this is not really, I don't think this is supposed to be like that. There's a screw missing. Aww. And as always on those boards, everything here is everything is socketed. Oh man. Now how do I, yeah, there we go. Alright, so here's the mounting shot. What's inside this cover? Wow, this is the input attenuation board. And you can actually see those two relays. There are other 4 on the back. But anyways, this is so cool. Look at the variable air capacitors there. Wow, that's some high precision. Oh, this is the coupling capacitor right there. So here's a little close-up on the actual attenuation board. You can actually see those 2 identical sections here, because this is the minus input, this is the positive, this is the negative input, this is the positive input. And the board material, as usual with Tektronix amplifiers, is a very delicate, very special kind of material. It's polyphenylene oxide, or PPO, which is a thermoplastic polymer. Was actually widely used back in the days for RF applications. It has excellent electrical characteristics, and has very good also aging properties. And look at those cylinders there on the output amplifier board, and those are resistors. Actually, very special set of matched 1 kilo ohm resistors. Alright, so what I'm gonna do now is I'm gonna actually remove all the little knobs on the front so I can access the front panel cover, and hopefully remove it and clean also everything, because that is really filthy. So I have to do that in order to access the mechanism inside this part. So alright, so since there are not many tutorials on this, and certainly not much information on how to access the actual mechanism there, I'm gonna provide you some at least what I'm gonna do to get to the actual mechanism and fix it. First thing that I did was to remove the front faceplate. And in order to remove this, you don't have to remove the 2 B and C connectors. You just have to remove the all the knobs, the actual grounding stud, the grounding banana jack right there, and also the VC out, which you have to desolder from the bottom there. I don't know if you can see it, but it was actually soldered there. Have to desolder it in order to remove the actual little connector on the front. And this just it's a press fit, so just remove it, pry it out with a screwdriver, being careful to not scratch it, obviously. Also, the little lens for the mechanical readout here comes off, and a little lens for a lamp. So yeah, be careful to not lose them. But anyway, after that, what I'm actually doing is I'm gonna remove the this top cover here, and also because I really want to clean it. It's really bad. So there are 4 screws, 2 on the front here and 2 on the back, and there are other 4 that connect to hold the boards down. It's a little nightmare to to access this this part. All right. Now we should be able to remove the mechanism by unscrewing those 2 screws on the front, and this should slide out. All right, so this thing here is the lamp assembly. So the decimal point is provided by those 3 incandescent light bulbs. So if you have to replace those, this is the way to do it. And this whole thing should just, just come off like that. And it's a little bit hard because, you know, it's a mess of wires, but there we go. Now it's undone. Have to take a bunch of pictures on the connectors, and yeah, gonna try to see what's inside here. All right, look at that. That was a little bit painful, but you know, just I took a lot of pictures of the all the connections, so now I can reassemble those correctly. So this is the whole mechanical part, and there are 4 screws that hold this shield here, and which is nice, so dirt cannot enter into the mechanism. So let's remove those, and we'll see. Alright, so this is a little close-up of the mechanism. You can actually see this is actually beautifully done. Look at that. That is really, really nice. This is clockwork. But, you know, this outer part here, this outer knob, should move this gear that moves this other gear right there, and move this other gear right there. And this one is attached to the switch here. All right. But you can actually see it moving, but it doesn't because the gear, this gear here, is broken. So you can actually see the gear, it's split in half. Alright, so this is a little bit more problematic than I thought. So as you can see here, this gear here, this last gear, it's completely broken. This tooth missing too. So yeah, man, I don't really know where the tooth has gone. I searched on the inside, but there doesn't seem to be any residue. So perhaps someone already was in here trying to repair this thing. Alright, so I'm a little bit out of ideas because I don't have a replacement gear, obviously, and those are this part, and it's basically unobtainium, and I don't have a 3D printer. So what I'm gonna do, it's pretty desperate, but hopefully it will work. I'm gonna basically glue this gear back together, and with the 2 parts epoxy, and to, you know, press it down a little bit, I'm gonna use this cable tie to really press into it and hold it together. yeah, gonna mix those two parts right there and basically inject the glue around the gear inside on the bottom. So yeah, hopefully. Alright, so yeah, it's not the most beautiful thing in the world, but it works, which is the most important thing. The proper way to do it would have been to just change the gear, this gear here, change it with a new one, perhaps 3D printed, whatever. But I don't have a 3D printer. I don't have a machine shop, so that I can actually machine a new wheel, whatever. So what I did is used some epoxy glue, glued this gear back together. It was split in half here, and then with a stainless steel piece of wire, I just wrapped it around, and this is actually holding the gear together, so it won't come off again. And it's very tight, and yeah, it works. Yeah, I know it's a little bit crude, but it works. Look at that. It works just fine. So yeah, this is my solution to repair the mechanism. Yeah, crude, but it works. Alright, so with that sorted out, now there's another problem, obviously. Yeah, this digit shouldn't be a 3, but a 0. So what I'm gonna do is unscrew a little bit this gear here. Those are some setting pins there. So we'll actually pull it up a little bit so it comes detached from the main gear, which is under here, that is responsible for the turning of the digit. And I'm gonna manually turn the digit so to actually have a 0, and then I'm gonna pull it back and tighten this thing up again. Alright, so I detached this gear here, so the other gear, which is on the bottom, is free to move. So I can now, without moving the actual switch, can now turn this thing back to 0. Actually, I'm gonna turn this thing back to 3. So because in order to access the set screws, I had to just switch it a couple of times, counted 3. So now I'm gonna put this thing back. Hopefully it does. Alright, so 3. And now you can see it, but alright, it's a 3. There should be a 2, 1, and 0. There we go. Now it's fixed. Nice. Alright, so now it's yeah, the glue is set, and is everything alright. I'm gonna reassemble this thing, put the cover back on, like that. I love the machining of this thing, it's so nice. And I'm gonna reconnect everything, and yeah, I'll come back soon. Alright, so it's time to test this plugin. So I have my 7603 oscilloscope mainframe, and yeah, let's turn it on and see if it works. Hopefully. Yeah, I don't see a trace. Alright, let's put it to ground. Both. And oh, we have a trace. Oh man, that's really bad. Look at the balance here. Alright, so that's there are some some contacts problems. Let's see if I can. Oh my god, look at that. Alright, so I do think we have some bad relays inside here. Yeah. Oh man. Alright, so Houston, we have some contact problems. Look at that. Look at that. This should be ground. Ground on both channels. Do nothing, but if I press identify, I hear some relays inside, and it may come good. There we go. There we go. So we should actually see a 4 volts. 4 volts peak-to-peak signal, but we do have nothing. The DC balance works, which is nice. Ah! You saw that? Ah, there we go. That's nice how, you know, persistence, long persistence display is good for that. Ah, there we go. There we go. That's our signal. Let's, there we go. This is our signal, and it's alright. It's working. And now it's completely gone. Alright, so I have the microphone that is almost inside the oscilloscope, and I'll let you hear the relays switching even if I'm not touching the thing. So here we go. I'm gonna press identify. See that? That I'm not touching the thing, and the relays are. But wait! What do you know? I just sprayed some contact cleaner and lubricant to into the little micro switch that was here on the identify button, and now I'll switch to AC. Have the calibrator, and that's a beautiful trace. And that's not moving. Just, you know, I also reseated all the relays in their socket, so that might actually have helped. But, yeah, working again. Beautiful. Look at that, that is almost calibrated. Have a 4 volts, exactly 4 volts. Peak-to-peak signal, and as you can see, I'm at 2 volts per division. That is almost perfect. And obviously the comparison voltage setting here works too. I can offset the thing just nicely. This is the positive and negative. That's working really quite nicely. Perfect. Very nice. So the step attenuation balance is a little bit out, so I'm gonna adjust it a little bit. So should be in the center. That's a little bit out. Now it should be just perfect. Yeah, perfect. Alright, so let's actually do some test example here. I have the manual that says everything. But anyways, let's for fun, let's measure some voltage using the comparison voltage feature. So I have a power supply set to almost exactly 1.5 volts. You can actually see there it's a 1.50187 whatever, and that's good enough. Let's attach at least right there. As you can see, the trace is jumped up 3 divisions, which is correct. I'm currently at 0.5 volts per division. That is spot on. Let's shift the trace down so that we can actually measure here the voltage. So here, obviously, the trace is, if it is grounded, set right here on the middle. Go DC, and that's the voltage. Set to positive readout, and the negative input set to voltage compare. So let's compare it. Let's shift the trace until we go down to the center right there, and let's measure it. Let's read it. It's reading 1.51 volts, which is, you know, it's in the ballpark. Here's another example. Have another power supply that can supply up to 60 volts. Have it set to around 50. Let's see the exact voltage. So let's bring the trace down. 2, 3. So it's 10. So it's 30, 40, 50. There it is. And it's a little bit less than 50 volts, so let's switch down to 40, and let's increase the value here on the fine control. It's gonna take a while. So it's 45, 46, 47, 48, there it is, 49, and that's almost 50. There it is. And it's reading 49.86. Let's see if that's correct. Set the meter. Well, almost. 49.84. And the last example, let's say we want to set this power supply exactly to 3 volts. What we do, we set 3 volts right here on the readout. Here is positive DC coupling. The negative input is set to voltage compare. Let's set this thing to exactly 3 volts. Let's increase the voltage. There is the trace. Put it on the center. And now the power supply is set exactly to 3 volts. Let's check it with the multimeter. And that is really close. 2.993. Very nice. Alright, so how cool is that? Now I have 3 traces because I have this 7A12, have the 7A13 that allows me to have double trace with this one and another one there. So 3 traces on this oscilloscope, which is really cool. And yeah, that's basically it for this video. I'm not gonna calibrate the thing because I don't have the full equipment necessary to perform a full proper calibration of this thing. Instead, perhaps in the future I'm gonna actually send this to a lab for proper calibration. Actually, it's pretty good in tolerance, so I checked a few things, and It's actually within tolerance, so yeah, it doesn't really need calibration, but you know, perhaps in the future I'm gonna send it to a lab. But anyways, that's basically it for this video, and as always, thank you for watching, and I'll see you next time. Bye!